Welcome to example 2 of a being a whole number. You can continue on your same flowchart that you printed out for the first video. For this example, my equation is y equals 3x squared plus 1. Now we did one like this earlier this week where there was only 2 terms and we were missing a term. Now you'll never be missing the first term because having an x squared in this problem is what makes it a parabola problem. So you will always have your a term, but you might be missing your b term or your c term. So we got to figure out which one is missing and which one is there. Since my plus 1 does not have a letter x next to it, this is my c term, which means that we are missing our b term. So in this problem, b is 0. And a is 3 and c is 1. Okay, since my a is positive 3, this parabola will open up and it will have a minimum. My axis of symmetry is negative b, which is 0, over 2 times 3. Anytime your b is 0, your axis of symmetry is just going to be x equals 0. Then we're going to plug that back in. And again, when your axis of symmetry is 0, it's just going to make this whole term go away. 0 squared is 0. 0 times 3 is 0, and 0 plus 1 is 1. So, if your axis of symmetry is 0, your y coordinate for your vertex is just going to be your letter C, which is 1, 0, 1 for my vertex. That also happens to be my y-intercept. When your letter B is missing, your vertex and your y-intercept will be the same. That will always happen. All right, let's graph. So x equals 0, vertical line on the 0, which is the origin. So it's a vertical line going straight through the y-axis. And my vertex, again, is on the y-axis. It's my y-intercept at 0, 1. All right, our special ordered pairs are going to change again. So this time, though, I'm multiplying my y-coordinate by the number 3. So it's an even bigger change. So my first special ordered pair, instead of 1, 1, is going to change into 1, 3. So remember, the bigger the A, the steeper, the quicker it's going to rise. So starting at my vertex, not the origin, vertex, over 1, up 3. It's already gotten super skinny right here. Normally, next I would do 2, 4, but that's going to change to 2, 12, and I actually can't even fit that on my graph, right? 2, 12 is going to be somewhere like way up here. So remember, it's going to get really, really skinny. Now, there is going to be a spot for you to write down what your new special ordered pairs are. So even if you can't graph them, you do still need to write them down. 1, 3, 2, 12, 3, 27. And you have to graph any that do fit. And if they don't fit on the graph, that's okay. I understand. I know that they're not going to fit. All right. Our last question is to state the x-intercepts. In this problem, my vertex started above the graph and then it went up. And so since it's above the x-axis, it's never going to go back down and touch. And so there are no x-intercepts. You do need to write the word none or no x-intercepts. You cannot write the number 0. If you write the number 0, that means it's touching at the origin, and it's not. So you need to write a word for that one. All right, this concludes our second video.